Hello students, welcome to the next session regarding discussion of belt drive problems. Already we have completed the theory part related to the procedure regarding how to calculate the length of belt for the open belt drive case, cross belt drive case, then the ratio of belt tensions in a flat belt drives, as well as we have learned regarding the power transmission and velocity ratio. So related to all this, we will be discussing some simple problems in this particular session. Let us see the problems one by one. So the first question is, it is required to drive a shaft A at 600 rpm by using a pulley of 150 mm diameter on another parallel shaft B running at 240 rpm. What would be the diameter of the pulley on the shaft A, and also find the velocity ratio? This is the question given. Remember always, the first important thing is, in a belt drives as well as for the gear drives, we need to identify which are the driver and the driven cases. So to understand that, we need to read the question carefully. So if you read the question carefully, it is said that to drive, it is required to drive a shaft A, which means the shaft A, it is able to run with some power coming from another shaft. So it is said here to drive a shaft A at how much speed? 600 rpm. So shaft A, it has to be driven and it has at 600 rpm, which means the driven pulley here becomes the pulley mounted on shaft A at 600 rpm. By what? Using a belt with a pulley of 150 mm diameter. Yes, there's a pulley of 150 mm diameter. Where it is there? It is there on another parallel shaft B, which means another shaft automatically, once the shaft A becomes the driven pulley, then the pulley mounted on shaft B becomes the driver pulley, and the diameter of this driver pulley is 150 mm. And this driver pulley, it rotates at 240 rpm. So with these conditions, you need to find out the diameter of the driven pulley at shaft A. Along with that, even the velocity ratio also. So now, once we are understood these things, let us note down the points regarding how we are able to categorize them into driver and the driven cases. So first, take out the given data. As I told you, this is the driven pulley. These are the conditions for a driver pulley, and we need to find out the diameter of the shaft on A. So given conditions. So as I told you, shaft A is receiving power, which means it is a driven pulley. So what is the speed? 600 rpm. Speed 600 rpm, and it receives power from a pulley of 150 mm diameter. 150 mm diameter, that is the driver pulley, whose speed is how much? 240 rpm. Now what we need to find out? The diameter of the pulley on shaft A, which is dA. And along with that, even we need to find out the velocity ratio also. So already we have discussed one small derivation part regarding how to estimate the velocity ratio. If you use that particular equation, even will get this diameter also as well as the velocity ratio also. So next, solution part. The solution, if you observe, using the velocity ratio. So how we write velocity ratio? Always it is nothing but the speed of the driven pulley to the speed of the driver pulley, which is equal to the diameter of the driver pulley to the diameter of the driven pulley. So you should remember this equation correctly. If you are able to remember this one, so automatically you will get the correct solution. So always keep in mind, speed in the numerator part, speed of the driven pulley comes here, speed of the driven pulley, and then at the bottom, speed of the driver pulley, which is equal to, now on the other side, it becomes diameter of the driver pulley divided by diameter of the driven pulley. This ratio you need to remember correctly, then only it becomes very easy to analyze the things. Now next, so how we write speed of the driven is the thing, but it is NA by NB. This is the driver pulley, is equal to diameter of the driver, that is diameter of the driver is here dB divided by dA. This is the driven. You need to find the value of dA. So what is the value of dA you get? It is 0.06 meter or it is 60 mm. One part of your question is over. Another part left is regarding velocity ratio. So velocity ratio, this is nothing but this is the velocity ratio itself. That is the speed of the ratio of the speed of the driven to the driver itself. It is the velocity itself. What it means, 600 by 240, whatever the ratio you get, it is nothing but it is the velocity itself. So if you take the ratios, what do we get? So let us see the things. See, velocity ratio is Na by Nb, that is speed of the driven divided by speed of the driver. 600 240, that is 5 by 2. Already the ratio given is 5:2. So in this way, you need to solve the problem. Now moving on to the next problem. So if you read this question carefully, here also in this problem, he says there is a shaft which is running at 100 rpm to drive a parallel shaft at 150 rpm. The pulley on the driving shaft is 35 centimeter in diameter. Find the diameter of the driven pulley. Calculate the linear velocity of the belt as well as velocity ratio. So here also the conditions are given with respect to the driver and the driven conditions. But first we need to identify which is the driver and which is the driven case. So if you read the question carefully, there is one shaft which runs at 100 rpm. It is running at 100 rpm. When this is running at 100 rpm, it is driving another parallel shaft 150 rpm. What it means, the shaft running at 150 rpm, it becomes a driven shaft, and 100 rpm shaft becomes a driver shaft. Now the pulley on the driving shaft, that is the pulley on the driving shaft, how much it is in diameter? It is 35 centimeter in diameter. The diameter of the driving shaft is 35 centimeter. You need to find out the diameter of which one? Driven pulley. So along with this, in this problem, another one and additional condition given is you need to find out the linear velocity of the belt, and already you need to find out even the velocity ratio also. So now once we have seen that the 100 rpm is a driver pulley, then its diameter is 35 centimeter. With a driven pulley, its rpm is how much? 150 rpm. You need to find out the diameter of this driven pulley, and then along with that the velocity ratio as well as linear velocity of the belt. So whatever the conditions are given, take down these conditions and write them in a neat form, that is a given data. So now the given data, what do we get here? So here shaft 1, I have taken this as shaft 1. It is as per the statement given is a shaft which is running at 100 rpm. It is driving a parallel shaft, which means this becomes a driver shaft. So driver shaft speed is how much? 100 rpm. It is driving a parallel shaft, means this is the driven shaft. It is 150 rpm. Then the pulley on the driving shaft, that is the driver shaft itself, how much it is? 35 centimeter or 0.35 meter diameter. We need to find out the diameter of the driven pulley, that is d2. Along with that, another thing is linear velocity of the belt as well as velocity ratio. First, let us find out the value of diameter d2 using the same velocity ratio equation, that is velocity ratio is equal to, or is the ratio of the speed of the driven, the speed of the driver, which is equal to diameter of the driver to the diameter of the driven. So already we have categorized the things which comes under driver, which comes under driven. Substitute those things with their suffixes correctly. So according to this now, which is the driven, suffix to n2 by n1, n2 by n1 is equal to d1 by d2. So you have the conditions, substitute, you get the value of d2. d2 value is how much? It is around 0.2333 meters, or it is 23.33 centimeter. That is one part of your problem is over, that is the diameter of the driven pulley. Now we need to find out linear velocity as well as velocity ratio. So first we will find out the velocity ratio itself, as we have the terms directly given itself. So for the velocity ratio, if we take the ratios of n2 by n1, you will get the velocity ratio that is 150 by 100. That is a 3:2. You will get in the simplification as your velocity ratio. So velocity ratio is n2 by n1, 150 by 100 or 3 by 2. It becomes 3:2. That is your velocity ratio. Another additional thing in this problem is linear velocity of the belt. So what is linear velocity of the belt? Yes, linear velocity of the belt is v, and this v, it is equal to, v is equal to pi d1 n1, or it is equal to pi d2 n2. So v is equal to pi d1 n1, or it is equal to pi d2 n2. You may take any of the one terms. You may take pi d1 n1 or pi d2 n2. You will get the same linear velocity of the belt itself. So I have taken v is equal to pi into 0.35 into 100. So using this, we get the value in terms of meters per minute, because the value of n which is given, that is the speed, it is in rpm. So when the resulting answer you get, it is in terms of meters per minute, but generally the velocity we are writing in terms of meter per second. So if we divide this value by 60, you will get the resulting answer in meter per second. This is how we find out the linear velocity of the belt. Now moving on to the next problem. So next problem, if you read the problem carefully, he says there is a cross belt drive. The difference in tension between tight and slack sides is 1200 Newton. If the angle of contact is 160 degrees and the coefficient of friction is 0.28, this is the coefficient of friction. Find the tension between slack and tight sides. So you have to find the tension in slack and tight sides. Already in our discussion part of the theory, we have designated that on a tight side, the tension is abbreviated as capital T1. On slack side, it is abbreviated as capital T2. So we need to find out the tensions T1 and T2 in this problem. And he has given us the conditions that the difference in tension between tight side and slack side. So if you observe this carefully in this given particular question, it is said that difference in tension between which tight and slack side, that is T1, T2, difference is minus. T1 minus T2 is how much? 1200 Newton. Angle of contact, that is theta, it is 160 degrees, and there is some amount of friction developed, that is coefficient of friction, that is 0.28. With this, you need to find the value of tension in tight side T1 as well as the value of T2. You need to find out these things. So to find out these things, we take the help of the equation for ratio of belt tensions. So using that, we can move forward to find out the value of T1 as well as T2. So let us find out, and first write down the given data in a correct manner. So this is our given data. As I told you, difference in tension between tight and slack sides is 1200 Newton. That is T1 minus T2 is equal to 1200 Newtons. Angle of contact, it is 160 degrees. Please remember carefully, whenever you are solving the problems on belt drives, especially when the value of theta is given, do remember that this theta value should be in radians. If it is not, please convert this into radians by using this equation, that is theta into pi by 180. Theta given for us is 160 degrees, so 160 into pi by 180, because the value of theta for finding the ratio of belt tensions, it is written in terms of radians. So take care and write the value in radians itself. This is very important step. Now once we have converted this into radians and we have written the other part also regarding the value of coefficient of friction mu is equal to 0.28, let us use the equation of ratio of belt tensions. So what is the equation? Ratio of belt tensions is T1 by T2 is equal to e to the power of mu theta. E to the power of mu theta. Mu value is given to you. Theta value you have written in radians. So once you write this one and simplify, you will get the value of T1 by T2 is equal to some answer. Okay, so let us see what happens next. So T1 to 2, we have so we have inserted the values given to us, that is mu and theta. So we get the resulting value as T1 by T2 is equal to 2.185, or it becomes T1 is equal to 2.185 T2, 2.185 T2 after simplification. So we need to find the value of T1 and T2. If you move to the given data, what is the value of T1 from this given data? You can write this T1 as nothing but T1 is equal to 1200 plus of T2. Yes, from your given data. The same I have written here. So using that, what happens to this particular equation? The value of T1, I have taken it as 1200 plus T2. The other side we are having in terms of T2. So automatically from this one, what do we get? We get the value of T2 directly itself. So the T2 value becomes 1012.65 newtons. Now, once you substitute the value of T2 in this particular equation, the resulting term T1 is pending. And this T1, you can find out that is 2212.65 Newton. So, tension in the tight side is 2221.65 Newtons, as well as on slack side is 1012. To the next part. So this was the question where we had, this is the next question. Before that, let us brief once more these things on this previous question. So in the previous question, you can see here the difference in tension between the tension tight and slack side given in the question is 1200 newtons. The angle of contact given is how much? 160 degrees. You need to convert this into radians by multiplying by pi by 180. You get it in radians. Coefficient of friction is given to you as 0.28. Then the ratio of belt tensions T1 by T2 is equal to e raised to mu theta. Once you simplify, you get the values as T1 by T2 is equal to 2.185, or it becomes T1 is equal to 2.185 into T2. Now 1200 plus T2, the value of T1 from this equation I have written. T1 is the thing what it is, 1200 plus T2, that is I have substituted here. You get the value of T2 as 1012.65 newtons. So once you get the value of T2, substitute in this particular equation, you get the value of T1 also, that is 2212.65 newtons. That is the tension on the right side as well as the slack side. Moving on to the next problem. So in this problem, if you go through the question carefully, it has been clearly suggested that to transmit a power of 20 kilowatt, we have to transmit a power of 20 kilowatt between two parallel shafts by means of a belt drive arrangement. The driving shaft is nothing but it is a driver shaft itself. It is rotating at how much? 150 rpm, while the driven shaft is rotating at 250 rpm. The distance between the centers of the two shafts is 2.7 meter, and the pulley mounted on the driven shaft has 60 centimeter diameter. Assuming the coefficient of friction between the belt and the pulley rim as 0.25, determine the length of the belt as well as belt tensions, length of the belt and belt tensions for open belt drive and cross belt drive. So in this question, what you need to find out? First, you need to find out the length of the belt and tensions T1, T2 for first case, that is open belt drive case. Again, for the second case, you have to find the same things, that is the length of the belt and tensions for cross belt drive case. So there are two cases in these problems. So before we go for a solution, let us see the things one by one. He says we need to transmit a power of how much? 20 kilowatt between two parallel shafts using a belt drive arrangement. He says the driving shaft rotates at 150 rpm, which means the driver shaft is 150 rpm speed. Along with that, the driven shaft speed is how much? 250 rpm, 250. Now the distance between the centers of these two shafts. So distance between center of two shafts, we have written the symbol as x, whose value is how much now here? 2.7 meter. And the pulley mounted on the driven shaft. Remember, he has given the pulley mounted on which shaft? Driven shaft. How much it is? 60 centimeter, 60. He has given the coefficient of friction, mu he has given between the belt and pulley remains how much? The value is 0.25. With this, you need to find out the length of the belt and belt tensions for first case, that is the open belt drive case. This is the first case. And repeating the same, that is the length of the belt and the belt tensions for a second case. Which is the second case? It is the cross belt drive case. So you have to repeat the procedures for two different cases. One is the open belt drive case, another one is the closed belt drive case, cross belt drive case. So let us see the things one by one. So the first thing is note on the given data. So he has said the power transmitted is 20 kilowatt, right? Write the things under driver and driven columns. Driver speed is how much? 150 rpm. As already told, he has given the speed of the driven shaft 250 rpm with the driven shaft diameter is how much? 60 centimeter, or it is 0.6 meter. We don't know the diameter of the driver shaft, that we need to find out. Along with that, he has said distance between the center of the shafts, that is x, 2.7 meters. Coefficient of friction he has given 0.25. We need to find out length of the belt LO as well as length of a cross belt drive, that is LC. And for both the cases, you need to find out T1 and T2. So for both the cases, you need to find out the value of T1 and T2 itself. So how it is written? For the first case, you need to find out the value of T1 as well as T2, that is the open belt drive case. Similarly, for the cross belt drive case also, you need to find out the value of T1 as well as the value of T2. Remember the ratio of tensions, that is T1 and T2, for both the cases, they don't remain the same. They are changing. So don't say that if I find the value of T1 and T2 for one case, it is the same value for the second case. So no, it is not the case. So you have to find out separately, and those values will be separate for both the cases. So let us move to the next part regarding the solution part. Let us see how we get the solution. Yes. So first solution for the open belt drive case, we shall begin. So for the open belt drive case, the length of the open belt drive equation is pi of R1 plus R2 plus R1 minus R2 whole square by x plus 2x. Already we have the value of x given in the question. He has given the value of the diameter of the driving shaft, that is D2 according to our question. So means we are having the value of even R2 also. We don't know the value of R1. So if you see the value of R2 is known to us, R2 is the thing, but it is D2 by 2. We get the value around 0.6 meter. Similarly, we need to find the value of R1, but we don't know the value of D1. So how we can find now this one? Using our velocity ratio equation. That is, velocity ratio is the speed of the driven, the speed of the driver is equal to diameter of the driver to the diameter of the driven. So N2 by N1 we know D2 also, then we can find out now D1. So if we substitute the values, we get the values D1 as 1 meter or the value of R1 as 0.5 meter. Now once you substitute these things in this particular equation, you get the value of the length for the open belt drive case. So substituting the values of R1, R2 and X in equation 1, what we get? The value of the length of the belt open belt drive case. So we have got the value. So we have substituted here, we have simplified, and we have got the resulting value. Next, now we need to find out the belt tensions for the open belt drive case. So already we know the question, that we know the equation, that is T1 or T2 is equal to E raised to mu theta. But we don't know the value of theta. Now we need to find the value of theta. How we can find out? Using our equation of angle of contact for which case? Open belt drive case. This is very, very important. In the previous session regarding the discussion of the tension of belt drives, I had given there how to find out the angle of contact for both the cases, open belt drive case as well as cross belt drive case. Now we are estimating for open belt drive case. So for the open belt drive case, the equation is theta is equal to 180 minus 2 sine inverse of R1 minus R2 by C whole bracket into this resulting value you get in degrees. The resulting value from this one you get it in degrees. But as I told, for this we need to substitute the value of theta in radians. So here we multiply by pi by 180 when we get in the form of radians. We get it the value in the form of radians. So now let us get the value and simplify. So once we simplify, we get the value as 2.9936 radians. So once we have these values, we can go for finding the ratio of the belt tensions T1 by T2. So once I substitute this value, I get it as, so I have substituted the value here. Mu is already given in our question. Theta value we have just now derived. So the value of T1 by T2 ratio is around 2.1136, or the same I can write it as T1 is equal to 2.1136 T2. We don't know the value of T1, or we have to find the value of T2. Then only we can find separate the value of T1 and T2. For this, another hint given in this question is regarding the power transmitted. So using that equation, you can get the value of T1 and T2. So let us see how we can find that one. So our power transmitted equation T1 minus T2 by 1000. P is given. T1 is equal to, we have got some value in terms of T2, but the another important thing left is V, that is the linear velocity of the belt. So this linear velocity of the belt, how we are finding using this term, that is pi d1 n1 is equal to pi d2 n2. So once we substitute using this one, we get the value of V, that is in this particular fashion. Pi d1 n1 is equal to, we substitute the values, the resulting value of the velocity, which is coming here, it is in terms of meters per minute. Please remember why we get in meters per minute, because the speed given in the question, it is in terms of RPM. So we get it in meters per minute. So normally this velocity what we are writing, we write it in meters per second. So if you divide this particular answer by 60, you get the resulting value in meters per second. That is very, very important. So once you get the value of velocity in meters per second, then you can go on for further simplification for finding in terms of P is equal to T1 minus T2 into V. So once we have found out the velocity of V as 7.855 meters per second, let us put to the next part, substituting the value of V in this particular equation and finding the value of T2. So we substitute the values here, power as 20 kilowatt, T1 in terms of T2, and the resulting value T2 we get it here. So once we get the value of T2, you can find even the value of T1. Substituting the value of T2 in equation number 3, we get the value of T1. It is in this particular format. So this we get the value of T1 and T2 for the previous open belt drive case. Similarly, this entire procedure we need to repeat for the next case, that is the cross belt drive case. So let us see. So for the cross belt drive case, we have the length of the belt equation, LC is equal to pi of R1 plus R2 plus R1 plus R2 whole square by X plus 2X. This is the equation. Already we have found out R1 and R2, so you can substitute directly. You get the value of LC as 8.1506. This is the length for the cross belt drive case. Now go for finding the tension of the belt, ratio of the tensions for the flat belt drive case in the form of a cross belt drive. So that is T1 and T2 is equal to E raised to mu theta. So here again, as I told you previously, the value of theta, again we need to calculate for the cross belt drive case using the same equation of angle of contact. So angle of contact here for the cross belt drive case, here it becomes 180 plus 2 sine inverse of R1 plus R2 by C. So once you use this equation, again you get the value in terms of degrees, which you need to convert and calculate, to convert and get the value in terms of radians, that is multiplying by pi by 180. The resulting answer what you get, it is in terms of radians. It is in terms of radians. So the value of theta what we get now, it is 3.7436 radians. So now, once we get the value of theta, go for finding the value of the belt tensions T1 and T2. So T1 by T2 is equal to, substituting the values of mu and theta, we get the value of T1 by T2 is 2.5495. So again, writing T1 in terms of T2. And after this, we are using our power equation. P is equal to T1 minus T2 by 1000 into V. Already the V value we have estimated. So it is in terms of 7.855 meters per second. So once we substitute the value of T1 here in terms of T2, we can write the value of T2 as 1643.206 newtons. So once we get the value of T2, substitute in equation number 10, we'll get the corresponding value of T1 also. So we have substituted and we have got the value of T1 as 4189.353 newtons. So in this way, you can find out the tensions. Now, moving on to the next problem. If you observe for the next question, he says that for a belt drive, the angle of lap on a driven pulley, theta, how much he has given? 160 degrees. Coefficient of friction, it is given how much? 0.3. Along with that, he says maximum tension in the belt is how much? 1000, sorry, it is 10,000 Newton. Maximum tension in the belt is 10,000 Newtons. Find the initial tension in the belt. So, initial tension in the belt is nothing but it is a concept regarding when the belt drive is under stationary condition. When a belt drive is under stationary condition, we are finding the initial tension, which is represented as T naught. And this is calculated when the belt drive is under stationary conditions. So to find this one, we need to know the values of the tensions, that is T1 and T2. So once we know the values of T1 and T2, we can solve directly to get the value of the initial tension in the belt. So let us note down the given data. So as I told, convert this degrees into radians by multiplying pi by 180. You get it in radians. Always remember the tension in tight side is nothing but the slack side itself. Sorry, tension in tight side is nothing but the maximum tension. So the question given here said that there is a maximum tension. Maximum tension means it is a tension of the tight side. It is a tension of the tight side. So always remember maximum tension given is nothing but it is the tight side itself. So that is T1 10,000 Newton. We have the value of mu. So we substitute the ratio of belt tensions. That is T1 by T2 is equal to e raised to mu theta. Mu is available, theta is available, T1 is given, you will get the value of T2. Once we get the value of T2, we find the value of initial tensions. So T0 is equal to T1 plus T2 by 2. That is the average of the tight side and the slack side of the belts. We get this value as this much, 7163.22 newtons. This is the initial tension in the belt. These are some of the problems related to the belt drives for your syllabus students. If you are having any more doubts or if you are having any more problems or you are not getting any of the solutions for such kind of problems, you can send me the comments by through the YouTube channel so that I will let you help for the other kind of problems also. Thank you, students.